Okay, 8th graders, I'm going to go through each of these pages one day at a time so that we can do some review that you worked on over the break. So let's look at number 1 first. So number 1 says, which label, I'm on page 1 obviously, which label or labels could replace A in the diagram below? Well, if you remember from looking at numbers and where they go. So basically there's real numbers, and then the next in would be rational numbers. So you could put rational numbers here. However, between rational and whole numbers, we also have, and I'm just going to make whole numbers a little smaller here, we also have a distinction of integers. So integers goes right there. So really, A could be considered either rational or integers, and so I would choose B. It is rational numbers or integers could be considered for A. All right, let's look at number 2. Between which two integers does the value of the square root of 88 lie? Well, remember, let's go over here. So the square root of 88, we want to think about it as between perfect squares. So it is between the perfect square of, or 88 is between the perfect square of 81 and the perfect square of 100. And so the square root of 88 is going to fall between those two as well. So the square root of 81 is 9. And we don't know the square root of 88, but it is between 9 and 10 because the square root of 100 is 10. All right, so looking over here, our answer then would be C. Number 3, James wrote the number 8,980,000 in scientific notation. Which number did he write? Well, remember that in order to write a number in scientific notation, it needs to, it needs to be a product of two factors, and the first factor is greater than or equal to 1 and less than 10. The second factor then is the power of 10. So let's rewrite that number over here. 8, 9, 8, 0, 0, 0, 0, and I'm not putting any commas in it. So our original decimal point is here. So if we're going to move the decimal point over so that our factor is between 1 and 10, it would go over 1, 2, 3, 4, 5, 6 times and end up here. So that gives us for the first factor 8 and 98/100ths. Now when we move the decimal point 6 places over, we're really dividing by a power of 10 to the 6th power, right? So the factor that we'd have to multiply by in order to keep the same number is 10 to the 6th power. So looking back at our choices, our answer would be D. All right, looking at number 4. The gray figure is the image of the black figure after a dilation. This is hard to see, but the gray figure is actually this smaller figure here. Okay. The easiest way to do this, to look at what happens to this bigger black figure, and I don't know how to change my colors yet in Notability. I'll get better at this as I go. But anyway, to go from this big figure to this smaller figure, what's happening? So I think the best way to do this is just look at a point. Let's look at this point. And this point, if you go, the x value for this is 2, and then the y value for this is 1, 2, 3, 4, 5, 6, 7, 8. So it's 2, 8. All right, and then on the same figure, but the smaller figure, the dilation, that would be the x value is 1 and the y value is 4. So you're going from 2, 8 to 1, 4. All right, now what's happening with those numbers? Well, to go from 2 to 1, you're dividing by 2. And to go from 8 to 4, you're also dividing by 2. Remember, dividing by 2 is the same as multiplying by 1/2. And so looking at our choices down here, the best choice would then be to go from x here to x here would be to divide by 1/2, and that would be B. And same thing for y, to go from y of 8 to a y of 4, you're dividing by 1/2. So our answer is going to be B. Okay, moving on. Number 5. The lengths in centimeters of 4 line segments are shown below. Which list shows the lengths in order from least to greatest? Okay, so we can start putting them in order from least to greatest, and we're going to have to do something with this square root of 10 to figure out what the approximate value of that is. So let's start with 3.12. I'm going to put them in order. 3.24 would be after that. Okay, and then 3 1/4 is going to be equal to 3.25. So far they're in order. So let's see where this square root of 10 falls between those numbers. Remember that to find the square root, or to approximate a square root, the first thing we want to do is decide what it's between in terms of squares. And the square root of 10 is going to be between the square root of 9 and the square root of 16. Well, so how far between the square root of 9 and the square root of 16 is the square root of 10? That's our question. And remember, we create a factor or a division. In the top, in the numerator, we're going to see what is the distance between 9 and 10. Well, that's 10 minus 9. And then in the denominator, we're going to see the distance between 9 and 16, and that's 16 minus 9. So if you find 10 minus 9 and 16 minus 9 is going to be equivalent to 1/7. All right, so 1/7. You're just going to take 1 and divide by 7. I hope you guys are remembering how to do this. This has been a while, but 1 divided by 7, and that's going to give us approximately 0.14. Now, we look at 0.14 and you go, well, that's the first number because we're comparing it to 3.12. No. Remember that this is the approximate distance. This is how far between these two numbers it comes. Remember, the square root of 9 is actually 3, and the square root of 16 is actually 4. So what we're saying here is this square root of 10 is about 14 hundredths between 3 and 4. So that gives us an approximate value for the square root of 10 as 3 and 14 hundredths, or 3.14. So that is going to go up here between 3.12 and 3.24. So we need to find the one that says 3.12 first, and then then the square root of 10. Oh, looks like B is the best answer for that. It goes 3.12, the square root of 10, 3.24, and then 3 and 1/4. So that works for us. All right, so our answer for 5 is B. Let's go on to 6. A figure is dilated by a factor of 2. Which statement is about the dimensions of the image is true? Okay, so remember, I need a little bit of space to work this out. I hope we can fit this in. Remember that when we dilate, we go from something called the pre-image to the image. So what they're asking about, which statement about the dimensions of the image is true. So this is the figure that we come up with after we've done something. So if it's dilated by a factor of 2, it means that to go from the pre-image to the image, we're multiplying by 2. Okay, we're multiplying the lengths, if you will, on the sides of the image by 2. All right, so here's an example of like what that might look like to go from, and this is not going to, let's see if I can make an actual rectangle looking thing here. All right, so let's say that this side is 2 and this side is 3. If I was going to multiply, and it's not really going to look exactly, but let's say now we're going from 2 to 3 to a 4 by 6 rectangle. That will be multiplying it by 2, right? Because 2 times 2 is 4, and 3 times 2 is 6. Okay, well, what happens to the perimeter? Because the questions here are being asked about the perimeter first, and then about the area. So let's figure out what happens to the perimeter, and then what happens to the area. So the perimeter of this first figure, the pre-image, if you will, let's go around it. Let me see if I can, yeah. All right, so we're going to go around it and count the distance. So 2 plus 3 is 5, plus 2 is 7, plus 3 is 10. So that's going to give us a perimeter of 10. All right, let's try a different color for this one. All right, so let's try to find the perimeter of the image now. That was the perimeter of the pre-image. So to go through here, that gives me a distance of 4, plus 6, that's 10, plus 4, that's 14, plus 6, that is 20. So now I've got a perimeter of 20. All right, well, what about the area? Well, remember, area is just length times height. So 2 times 3 is going to be an area of 6. And on this one, 4 times 6 is going to be an area of 24. So now let's look at what's happening between the perimeters and the areas. So the perimeters change from 10 to 20. That's multiplying it by 2. All right. And the areas change from 6 to 24. That's multiplying it by 4. So now we want to find an answer that says our perimeter multiplies by 2 and our area multiplies by 4. So the perimeter is, nope, this multiplied by 4 for the perimeter. That won't work. The perimeter and area of the original figure are doubled. Nope, they're not both doubled. Just the perimeter is doubled. That won't work. The perimeter of the original figure is multiplied by 4 and the area is multiplied by 8. D, the perimeter of the original figure is doubled. That means multiplied by 2. And the area is multiplied by 4. Ding, ding, ding. That's our answer. All right, number 7, last question. The points, blah, 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 all lie on the line y equals x. Anna calculated the slopes of the segment A, B, and segment C, D. What can she conclude? Well, this is a simple question, and if you are overthinking it, you may have gotten it wrong, but really all of these points are on the same line. So if you calculate the slopes between them, you're going to get the same slope for everything as long as it's a straight line. So our answer is A. All right, hope this helps.